Hello students, this is the second video, part 2 for chemical bonding. In this video we're going to be talking about covalent bonds, how to read covalent bonds when they're given to you, and how to write covalent bonds, or how to make the Lewis structures for them. So, start off, Indiana 8th grade standards we're covering are the same ones we were covering before. The whole goal is for students to be able to explain how atoms join together, forming molecules and compounds, and how this depends on the electron arrangements. Some helpful hints when watching this video. If you're watching this video while studying, please do not play video games while watching the video. Also, limit the amount of music you're listening to while watching this video. As you can probably tell, my voice sounds awful, and I'm getting over a cold. Another hint: use the buttons play and pause if you need to stop for a minute. You can also rewind or fast forward. Rewind if you miss something, you can go back. If you already know what I'm talking about, you can kind of fast forward. The other idea is to actually pause the video whenever I start an example and try and work through it yourself before watching the actual worked examples. We're talking about covalent bonds. Before we do that, we're going to have a little story about Timmy and Susie. They decide to go to their grandma's house, and they're both have an 8-pack of colored pencils. Timmy is missing his red pencil, while Susie is missing her green pencil. How is it that they could finish their pictures without a full set of their own colored pencils? If you're like most 2-year-olds, you know that you have to share your pencils. If they both share their pencils, they'll both have 8, and they'll both be happy. Just like an atom wants to have 8 electrons in its outer shell to be happy, they have to share with others. Here we have a picture and a more formal definition of covalent bonding. Basically, you have 2 hydrogen atoms. You can tell it's a hydrogen atom because there's a proton in the center, and then an electron cloud, which is the shaded part outside, and then another proton and another shaded cloud. If these 2 protons are near each other, the nucleuses are going to push away from each other. However, the electrons are going to be drawn towards both nucleuses. So you get some attraction from both electrons towards both neutrons, and some repulsion from the neutrons to, or protons to the nucleuses versus each other, and also the electrons want to avoid each other. Overall, this has a net effect of pulling the electrons together. When we're reading covalent bonds, you have to realize that for every atom that's in a covalent bond, there should be an electron dot diagram for it. If there's not an atom, that atom is not in the formula. Each line is going to represent 2 shared electrons. This means that both atoms can count those electrons when determining if they're stable or happy. Each dot that's in there represents a valence electron around that atom. So here's our first example. We're going to look at bromine combining with bromine. And the way this works is you have 7 bromine, or each bromine has 7 outer electrons, if you know your periodic table shortcuts, which are off to the side here. But the periodic table shortcuts show you that it tells you that each have 7, so they both want to gain 1. The formula for this problem is Br2, because there's 2 bromines. We know it's covalent for 2 reasons. The first is there's a line. Lines mean covalent. The second reason we know it's covalent is because they're both nonmetals. If they're both nonmetals, both on the same side of the periodic table on the right side, which is another shortcut. If they're both nonmetals, that means it's going to be covalent. Each bond, every single bond, always contains 2 shared electrons. So how many electrons are being shared in this example? It would be 2. How many electrons are not shared? You count up all the extra dots that are not out there, I get 2, 4, 6, 8, 10, 12. 12 electrons not shared. And then the bonds between Br and Br, there's a 1 bond between the two of them. If I look at the first element, Br, I have 2, 4, 6, 8 electrons. If I look at the second element in the Br, I have 2, 4, 6, 8 electrons. The line represents 2 electrons, and they're in both atoms. So we say yes, they are both happy, or both stable. The next problem is sulfur. Sulfur combining with sulfur. The formula for this one is going to be S2 because there's 2 S's. We know it's covalent because, again, there's a line connecting the two. And we know that they are both nonmetals. Each bond will contain 2 electrons. We have 2 bonds, so therefore there should be 4 shared electrons. If you look at the other electrons surrounding here, we know that there are 8 other electrons. How many bonds are there between the two? We have 2 bonds, also called a double bond. If there were 3 bonds, you would call that a triple bond. Looking at the first sulfur, 2, 4, 6, 8 electrons. The other sulfur,
Attention all
2,
7th grade boys
4,
basketball
6,
players and all
8
wrestlers.
sulfurs.
Your buses are out in front of the athletic entrance at this time,
so they are
you
both
can post to
happy.
be aboard. Good luck tonight.
The next example we have is on the screen. The formula for this one is going to be COCl2. Covalent because the same reasons before. They're all nonmetals and there's lines connecting them. Each bond will contain 2 electrons. So that means if there are 4 lines, we have a total of 8 shared electrons. The electrons not being shared, you count up all of them outside and there are 16. How many bonds are between O and each of the Cl's? There's single bonds between both the C's. Oops, that should say C and Cl. There's a bond there is no bond between O and Cl. And if I look at them and count them all up, we find that yes, they are happy. Next up, we're going to talk about how to draw Lewis structures, draw the covalent bonds. If you'd like, you can pause the video right now and write down those steps. We'll go over them as we go over the rest of the examples. Electron dot diagrams for hydrogen. Step 1, we figure out how many of each atom we need. This is given to us by the formula H2. So I draw 2 H's. I put a dot. For some reason I'm using blue. Okay. How many does each atom want to gain? Hydrogen only needs 2 electrons in its first shell, so both of them want to gain 1 electron. Next up, we need to line up the electrons. So we redraw, oops, we want a pencil. We're going to say hydrogen with 1 electron. The other hydrogen, we're going to line it up right next to it. Put that one right there. Get rid of that. And then the last step is we replace the 2 electrons that are shared with a line. So I write hydrogen, line, hydrogen. The line tells me that we are sharing electrons. So we know that that is the Lewis structure for this one. If you look at the first hydrogen, it has 2 electrons. If you look at the second hydrogen, it also has 2 electrons. Our next example looking at H2O. So we're going to have H dot, H dot, and then O. O has 6 dots. I know that because I know it's in group 6. And according to my periodic table shortcuts, it tells me how many valence or outer electrons there are. Hydrogen wants to gain 1 electron. The other hydrogen wants to gain 1 electron. And oxygen is going to want to gain 2 electrons. This isn't the charge, this is just telling me how many electrons both of them want to gain. That's step 2. Step 3. Step 3 says line up the electrons to get ready to share. The best way to do this is to start with the one that's going to gain the most in the middle. Oxygen wants to gain the most. Hydrogen's going to be on one side. The other hydrogen's going to be on the other side. That's my hydrogen electron diagrams. And then oxygen has 1, 2, 3, 4, 5, 6 electrons. Last step is replace the shared electrons with lines. H line, O line, H. Put back the other valence electrons for oxygen, and I get H2O. Here's another example of how it actually is working. We have 2 hydrogens. The electrons from the hydrogen atoms are attracted to the nucleus of oxygen, and then the oxygen electrons are attracted to the nucleus of the hydrogen. Another format of looking how the picture would look is the one down below. This one's not a Lewis structure, it's just showing what's going on with the overlapping of the electrons. Example 3, we're going to look at the just plain old oxygen, O2. We know from before and from our periodic table that oxygen has 6 electron dots, and there's 2 of them because of my formula. So both of them are going to want to gain 2 electrons. If they both gain 2 electrons, they're both happy. Step 3, we'll line up the electrons to be shared. Oxygen's going to line up 1, 2. The other oxygen lines up 1, 2, 3, 4, 5, 6. The ones that you want to share, or however many they want to gain, those are how many you line up next to each other. I redraw this. O with 2 lines, 2 dots, extra dots that we had from before are still on the outside. If I look at the first oxygen, it has 2, 4, 6, 8 electrons. The other oxygen has 2, 4, 6, 8 electrons. They're both happy. And then our final example is carbon dioxide. 1 carbon and 2 oxygens. You can see the picture right there of the electron diagrams. And then we decide that both oxygens want to gain 2 and carbon wants to gain 4. We line up, the carbon wants to gain 4, so it puts 2 on one oxygen, 2 on the other oxygen, and then it's going to combine a double bond with the first oxygen and a double bond with the second oxygen. So carbon has 2 double bonds. Each oxygen has a single double bond with carbon. Here's your chance to do some more practice. Try and figure out what each of these ones are. The last 2, nitric oxide and carbon monoxide, they don't end up having a full out, or they don't end up being polyatomic ions, but they still covalently bond. So this is the video. Hope you've enjoyed. Hopefully my voice will come back soon.